in this enriching webinar on transformer designing. Friends, will see how a distribution transformer, how a power transformer, how isolation transformer, how a unit auxiliary transformer, or a solar or UPS application transformer. Now, recently we added even the rectified transformer. I know Nandanji, Akash, and others will be happy to know that. We added rectified transformer apart from the other applications which I spoke about just now. And all this will be possible within 2 to 3 minutes. And what you get in this, you get the winding card, you get the core card, you get the insulation card, you get the quality card, including the short circuit and overloading characteristics. You get the tank and dissipation details. You get the complete bill of materials, all the raw materials with costing in currency of user's choice. Then this software also provides 15 customer submission drawings, 4 manufacturing drawings, and also 2-dimensional and 3-dimensional drawings. This software is an important tool for power engineers, electrical and mechanical engineers, designers, the proposal engineers, transformer sales engineers, utility companies who purchase large number of transformers. Friends, this versatile automatic transformer design software works for the rating between 5 kVA, 5 kilovolt amperes, to 80,000 kilovolt amperes, that is 80 MVA. And the maximum voltage class you'll be in a position to witness is about 138 kilovolts, 138 kV. This TDBro software outputs designs for dry type of transformers too, apart from the oil-cooled transformers. Friends, you are on mute to avoid the disturbance due to background noise. And please note, recording of this webinar is not allowed. Now, friends, I know you are as eager as I am to get going with this particular software now. Can we begin? Can I have okay in the chat box from you all? Friends, let's put okay. All of us are ready, eager to see how this TDBro transformer design software is going to enrich us with. Please put in chat box okay, or even O is enough. Yes, I see. Daniel, yes. Ravira, okay. Many of you, Abhijit, yeah, thank you so much. Friends, let's begin. What we see here, I draw your attention to the extreme top on the left side. You can see the main tab, utility, help, and logout. And below that is the design number. It is mentioned as a new. One can select if it is already stored something. Just put in that. Okay. Likewise, all the names will appear. And alongside that, you can see the basic information tab is there. And other tabs are not visible. Those will be visible moment we go from this particular page. Now, to begin with, you can see the design number. It's for webinar. It's 8th of May 2024 that is mentioned here. Then you can key in the maximum rating of the transformer. As I mentioned earlier, the type of transformer that can be designed is the distribution transformer, power transformer, rectified transformer, isolation transformer. It could be specific application for solar as well as UPS application, and also now rectified transformers. So let's go for the maximum rating of which you wish to see. You want to go for you want to go for 1500 kVA, that is 1.5 MVA, fine. And then the high voltage winding is 11,000 volts, and low voltage winding you would like to keep it 433. Okay. And the box that you see alongside the high voltage, it speaks about the dual voltage. That means you can set for the HV winding 2 voltages. You can just check in and see how that another cell will appear over there. Yes, that's the way. So if you want to see this, okay, otherwise let's move ahead. And by the side of high voltage, you can see the lighting impulse levels as well as the alternating current levels. All these are settable by the user depending upon the altitude at which the transformer is to be put to use. Similarly, for the low voltage winding, next is the reference standard. On top, you can see many reference standards are supported by this software for outputting the design of the transformer. It could be IS, IEC, ANSI, that is IEEE, CBIP, ECBC, SANS, European Eco Design, COAST, WAPDA. Now, these are all the reference standards used throughout the world in various parts of the world. You can choose the vector group. Many vector groups are supported by this particular software, starting with delta as well as star. You can see it is a three-phase transformer having two windings. Now, moment you go for the converter inverter duty transformer, there you will be in a position to see the number of windings. LV windings will be possible up to 6. Frequency of 50 Hertz or 60 Hertz is settable by the user. Coming to the efficiency, you can see there are 4 options given over there. Conventional is the highest losses. Level 1 is lower. Level 2 further lower. And level 3 is the lowest losses as far as what you can set on this particular page. The moment you see this, the question immediately that may come to your mind is, can I not set the losses on my own? Yes, definitely it is possible. But that is on the winding card. When we go away from this particular page, you'll be in a position to set it. Now you can select whichever you wish to. Okay, you want to go for level 2, doesn't matter. But this level 2 has nothing to do with the level set in by various standards. Impedance or the normal tap, you can key in whatever you wish to. Tolerance on the impedance, generally it is chosen based on the reference standard chosen. The flux density maximum, the core building factor, and next is the cooling. Cooling options are available: ONN, ONF, OFF. You can go for the dry type also, ANN. You can go for VPI type, vacuum pressure impregnated, as well as cast resin transformers. You can go for the ester oil, that's KNN, KNF. Even in the ester oil also, you have 2 options, synthetic as well as natural. Now you're talking about ONN in this particular case. Okay, good enough. No. Now the tapping you can go for, you have 2 options here. The off-circuit tap changer or on-load tap changer. You can also tick for the no tapping so that there will not be any tappings. Now you want to select OCTC. Okay, good enough. The tapping is on HV or LV. You selected HV. Then the tapping range you have to select from here. You can set whatever you wish to. You're selecting -5 to +5 with the step value of 2.5. That means it makes about total 5 taps here. The conductor material you can choose from here. It could be copper, it could be aluminum, it could be copper clad aluminum, 10%, 15% copper cladding, or you can also go for the combinations of copper and aluminum for HV and LV winding respectively. You can choose. Then you can go for the different core types. You have D type, S type, step lamp, elliptical core. Now these core types are various options are there, especially when you go for the low rating of the transformers. Can I see the whole range here? Okay, lower means you are going for 500 kV. Okay, to show. Oh, yeah, you can see here D type, S type, step lamp, wound shell and core, amorphous shell and core, elliptical core, rectangular core, and also EI core facility there for the smaller ratings of the transformers in 3 phases. Okay, you would like to see 500 or 1500, whatever you set. Okay, 1500, 11,000 by 433. Okay, divine 11 complying with the reference standard IC, and then it's at frequency of 50 Hertz. You have chosen it's ONN, and then you have chosen off-circuit tap changer on HV winding with tapping range of -5 to +5 with the step value of 2.5%. Now the type of tank you can select one out of many available here: radiator and conservator, seal type with radiator without conservator, corrugated fin with conservator, seal type without conservator, completely filled corrugated fin without conservator, elliptical tube radiator, again without conservator. All these options are there. You can choose what you wish to see. And then the class of insulation, you can choose from the available A, B, E. In case of dry, you will have many other options also. The ambient temperature is settable by the user. The oil temperature rise you can set. The winding temperature rise you can set here. The reference temperature at which you like all the losses and everything to be calculated, you can set here. Then this no load loss and load loss, what you see here, this changes automatically based on the efficiency level that you have seen on the top right. Moment it is level 2, you can see here, load loss is 9,329. You go for conventional, it will be higher. Yes, you go for level 3, that is the lowest losses, definitely it will go down. Okay, just verify now whatever you have done up till now, whether it is all the same thing. And then I draw your attention to the maximum current density you would like to set for the conductor. You can set different current densities for the LV as well as the HV winding. You are set at 2.3 now. Okay. Now let's recap what has been done. This is the job of 1.5 MVA, 11,000 volts on the primary side and 433 volts on the secondary side, with the lighting impulse level of 75 kV. Vector group is DY11. Reference standard according to which you would like to have the design done is IC. At the frequency of 50 Hz, the impedance at normal tap you are set at 6.25. Co-building factor of 1.15. It is oil cooled ONN with mineral oil. Then there's a tap changer on HV side, which has tapping range from -5 to +5 with the step of 2.5. The conductor material you have chosen it to be copper. The core type is D-type step lap. The type of tank you have chosen it to be corrugated fin type with conservator. And then you have set the temperatures. You have set the maximum current density. Having done this, now your job is to click on the next button. Let's go. Friends, moment you click on the next button, it takes you to the another page that's known as winding page. You can see on the top, the winding is illuminated now, under which it is written as transformer design wizard. And by the side of that, on the right hand side, you can see the job rating is mentioned as 1500 kVA, 11 by 0.433 kV. DY11 is the vector group and ONN is the cooling. Even I could finish speaking about what is there in the heading. Complete design for this particular transformer is ready, and you can see all the taps on the top are now illuminated or available to be read. You can see core card, insulation card, tank card, short circuit card, the bill of materials, the approval documents, the drawings in 2 dimension, the manufacturing specifications, then the manufacturing drawings in 3 dimension, and customer drawings in 3 dimension. Everything is available less than 1 minute that it has taken. Now, friends, let me speak about what all you get in this. I draw your attention to the table, smaller table on the right-hand side top, just below the rating that we have seen just now. The parameters, the units. The next column speaks about what are the parameters for the LV winding. And then the last 3 columns are for the HV winding at the minimum tap, the rated tap, and the maximum tap. You can see the area per phase is mentioned in the units, millimeter square. The current density per phase is mentioned. The length min turn is mentioned. Conductor length per phase is mentioned. The bare weight of the conductor is there. Insulated weight of the conductor is there. The resistance at the reference temperature. The I square R loss at the reference temperature. The AD loss for all the 3 phases. The gradient for the 3 phases. Everything is mentioned over there in that particular table. If I draw your attention to the table below that, another small table, you can see the parameters. Next column is the unit. Next is the design value. Next is the guaranteed value. And then rest two columns speak about the tolerance on the guaranteed values. You can see reactance is given in percentage. The impedance, the guaranteed value was set at 6.25 with the tolerance minimum 5.62 and maximum 6.88. The software has designed the impedance, designed the transformer with the impedance of 5.68. This software is such, friends, it will never design at the extreme levels. In this particular case of 5.62, it will always leave the tolerance of 2% as the manufacturing inaccuracies, so that whatever design it outputs will never have any issue in terms of the testing. The next parameter in that table is total I square or loss, the AD loss, the stray loss, the no load loss. No load loss, you can see 1711.96 watt. The load loss, software has designed at 10,250, and the resistance. Now, friends, when I read this particular thing in this particular table, you can see some of the values are indicated with the background in blue. Some of them are highlighted with the background in green, and some of them are in white background. Now, the parameters that are critical, what you have mentioned on the basic parameter page, that's the previous page, are given in green background. Those are the basic parameters on which the design has been done, like current density, like impedance, like no load loss, load loss. Other parameters that are there in the blue background cells are the calculated ones. And some of the parameters you can see here are in white background, like AD loss, the stray loss, the no load loss, the load loss. They are in white background. They are the editable cells. You can change them right here. AD loss, depending upon your production or manufacturing accuracies and the workmanship, you can set them. Similarly for the stray losses. Now, when it comes to the no load loss, you can change it right here. You can try to change it. 1722 is the maximum value, and it has designed at 1711.96. You can see how close that is to it. Similarly, load loss, whatever was set, it has designed at the extreme level, thereby making it the optimum design possible for the losses that it has achieved. The objective with the use of this particular software, friends, is to ensure that the lowest cost of raw materials is there for the design that you make. Now, when you change any parameters here, you can see the redesign button at the bottom, extreme right at the bottom. You can see the redesign button. The moment you click on this button, you can see the question comes, do you wish to continue with following parameters as fixed? Current density, whatever current density was set on the basic parameter page, would you like to keep it fixed? You can just check that and click on the OK, and it will redesign keeping these parameters with the change losses as the benchmark. Currently, it is showing in red, that is for the no load loss because you have changed it. But moment you click on the redesign, it will be possible to redesign another 1 minute time, and it will set to no load loss of less or equal to 1550. Okay, let's cancel this because I have to explain many things to you. Okay. Now, friends, you can see below that table, you can see the core grade. Core grade, the software has chosen it to be C120.27. You can see other options are available. You can change the way you want. Can you change and see? Yes. You can change, and accordingly, you can see the losses changing. Similarly, you can change the flux density. Similarly, you can change. Suppose you have, say, core loss. Suppose you have a core material which has a specific different core loss. It is not possibly listed in this core grade table here. You can put the core loss that is in watt per kilograms, and accordingly you can redesign the whole thing. Similarly, current density is also possible to change on this particular page. On the winding page, you can make it 2.4, 2.5, 2.6, whatever it is. You can also lower it, and accordingly, it will. You can click on the redesign button. Again, it will ask you a question whether you would like to keep this parameters as constant. Now, just click on the redesign and see what is it showing now. See, now we have touched other parameters, like we have touched the grade, we have touched the flux density, we have touched the current density. So it is asking us the question whether would you like to keep these parameters as fixed and still redesign it. Moment I say okay, it will redesign keeping all these parameters as fixed. Let's cancel this so that I'll explain the rest of the parameters. I draw your attention to the core area on the right hand side bottom. 526 centimeters square. The core diameter you can see 269 millimeter. The center length, that is the window width, is also indicated there. The leg length, that's the window height, is also indicated over there. Now, typically in case of any repair job that you would like to do, generally these parameters are fixed for you, and you can manage these parameters for the repair jobs by executing your options on all the cells that are given in the white background. Because on this page, all the white background cells are editable. Now I draw your attention to the left table. You can see the type of winding, unit, the LV winding, it is shown as layer, HV winding is shown as desk. Is there any other option for me? Yes, you can go for the file option for the LV. Can you go for HV? I have other option like layer and crossover. Yes, I can select that and then go ahead. Then winding direction is there. Then the terms, normal turns. You can see here it is the number of turns is editable by the user, 14. Can you change it to 15? Yes. Okay. There are many, checks are there as to how far you can go, and accordingly the design will be made. So it speaks about the limitations of as to you cannot go anywhere. So all those things are there in this particular software. Let's click on this and go to the next one. We are talking about the rated phase current. We are talking about the number of the layers, and we are talking about the tons per layer, the insulation between the disk and layers. All these white cells are again editable. The number of ducts, as many you want, the size of each duct, the type of conductor, it's a rectangular conductor. Okay, the type of conductor covering, whether you want a double paper covering or you want a triple paper covering, you want a super enamel, all these options are available for you. You can choose the number of axial and radial conductors. It's again settable by the user. It's all white background cells. Total conductors comes automatically. Then the conductor sizing. You can see here 16 millimeters is the conductor width given over here. You can change it. The thickness is 3.19. You can change it the way you want. The moment you change it here and go to the redesign button, you will be in a position to see it is asking you whether you would like to keep this parameter as fixed. Similarly, other options, the paper covering, and all lot of parameters are there, whether it is radial clearance between the core to LV, LV to HV, and there is a regulating winding when you go beyond a certain rating, about 10 MVA and plus. And that's where this regulating winding will also come into picture. Similarly, you can go down and see the other parameters. Yes, if I have to see from the bottom, it's bottom clearance, the top clearance, all these things are editable. Then the extra packing, if you wish to provide, the insulation for the gap between the coils, everything is settable by the user. And because of which this makes it a very, very user-friendly kind of software. Now, let me draw your attention to one button here by the side of the core grade. Okay, moment one clicks over there, you'll be in a position to see the bus bar size. Again, it is white background, so it is editable by the user. Then you can see the total losses at normal tap at 50% load. Now, especially when you speak about BIS and all, they specify the 50% load and 100% load. Then the total losses at the lowest tab, the highest tab, the zero sequence impedance, the impedance at the lowest tab, normal tab, and the maximum highest tab, turn scale factor. Then the face-to-face clearance, the transposition, all these are again editable by the user, number of circles, are editable. And then I draw your attention to another aspect. I draw your attention to the extreme left and bottom. You can see the two buttons over there. One is for the stack calculation, other one is for the ratio error. Let's go with one first. Friends, you are able to see here the information of the core coil assembly weight, the core thickness, the number of steps are 9. Now you can see in the table below there are 9 steps. Can we change it? Just change and see. Okay, if you make it 11, automatically the table changes. Similarly, if you want to change the step difference, it's possible to set over there. You can see below that the core weight is also given. Net area, the relative flux density, no load loss. Everything is given over there. In the table, you can see the width, the stack, the design stack, the net area, then the complete sizing along with the weight of each of them. Everything is given. Now, suppose for example, the first uh, stack is 255 millimeters width and second one is 245. Suppose I want to make it 250. Can I make it? Can I make the second one 250? Yes, software automatically adjusts and it will be done in this particular way. Now, friends, having seen the stack calculations, let's go and see what the ratio error calculations the software gives you with just click of a button. Friends, in this ratio error, you'll be in a position to see all the information related to the turns, how many tap turns, the number of steps, the step voltage, then the actual tap, HV winding turns, the number of positions, everything is there. And below that, you can see the table. As we have seen earlier, the total 5 taps. The maximum is +5, minimum is -5. And then how much is the voltage, how much is the ratio, how much is the design turns, the actual turns, the step turns, then the turns ratio, and also the percentage error for each of them. Everything is available in this particular friends. Now, friends, we have seen what all the information you could select or provide on the basic parameter page. We have seen how the complete winding card as well as all the other cards related to this basic information what we have selected or given. Within 1 minute, we have been able to see the complete design is getting ready, and we have just covered up till now only the winding card. Now let's go for the core card.
So based on the what core type you have selected on the basic information page, based on that, this core card is generated. You can see the core type, D-type step lap we have selected on the basic information page. Thereafter, core density, lamination per pocket, no load loss, then LV turns, center length, leg length, maximum number of steps, total losses at 50% load. Then the number of step lap option is available to edit. Then relative flux density, core loss on that flux density, then core filling factor, core diameter, net core area, and net weight. So I'll show you the printout with the diagrams. Here, you can see the figure 1 for side plate, figure 2 for center plate, and figure 3 for top and bottom view. And this type of core construction you will get. And the figures and the in this table, you can see the figure 1 for side table. And in that table, blade width, length, and the weight for each blade is provided. Same for the center and same for the top and bottom view. You may also export these reports in PDF, Excel, and Word. This company name, logo, and address is available to edit by the user. Now, next is the insulation page. On this page, you will get the details about the insulation in between core to LV gap, LV to HV gap, top and bottom clearances. Let's see first table. The top and bottom clearances arranged by these common blocks, winding block, permoud ring, and the common ring. And the total summation of these parameters are mentioned in the green color. Even the validation for green and red color is given here. You may rearrange the insulation as per your regular practice and achieve the total clearance. Same for the HV side. Then wedges detail is provided, cylinders detail is provided in between core to LV, LV to HV. Then the spacer details, rings detail, phase barrier detail, transposition, and the interlayer insulation detail. Now, the cells with white background are editable here also. The wherever are the cells with white background, that all are editable. Now let's see the left hand side part. In that table, you will get the information about frame part, frame length, width, height, and the thickness and bolt clearance. Then the frame sizes, that core dia, leg length, center length, blade width, and HVOD. Thereafter, you can see the detail about insulation grade, class of insulation, material, and the exact calculated weight. And these are the gap at actual gap and the insulation provided gap. Here also the validation. If you provide any wrong insulation, software will suggest you the right value. You can see the 5 is designed in the winding, but with this number of core to LV thickness, your insulation is going beyond this 5.5. So with this functionality, you can easily find out if you are entering any wrong value to avoid your mistakes. Then HV face-to-face gap is given here. And here the diagram will generate to understand where is the core gap, LV to HV gap, electrical and physical height. The detailed diagram with the dimensions is available in the manufacturing specification. Now next is the tank. On this page, you will get the detail about tank, radiator, and conservator. Now, you can see on your left hand side bottom corner, there are two images where live part core assembly is written. The first image you can consider as a top view, and A, B, C, and D are the clearances from live part to tank enclosure. And the same clearances are available in this table with the white background cells, and that all are the editable. These clearances are decided based on the what impulse level you have chosen on the basic information page. And based on that, even these clearances are available to edit also. And you can see the total transformer, total tank length, width, and height is available on this page. And it will impact on that. On your right hand side, you can see the tank dissipation, radiator dissipation, corrugated quantities, gap between the fins, number of gap on length side and width side, then fin height and depth, total fin on number on tank, then limit check functionality, oil quantity, and the fins weight. Friends, here the fin height and the depth is available to edit. It means you may rearrange your overall dimensions of the transformer. Then the conservator volume, conservator diameter, length, and oil in conservator. Here also you may change the conservator diameter and length will get changed automatically based on that. So whatever parameter are available here, for example, tank dimensions, radiator dimensions, conservator dimensions, the same dimensions you will get in the 3D diagrams. Now next, on your left hand side bottom corner, there is a button called as other accessories. There is a green color arrow. Once you click over there, the fitting and accessories for this 1500 kVA job, the software will suggest to as a by default, but you have a choice to select the fitting and accessories as per your customer specifications. You can see the tank side plate and bottom plate thickness suggested by the software based on the core coil assembly weight. And again, you have an option to choose the thicknesses, and based on that, again, the mechanical weight may vary. Then GOR type, magnetic oil gauge, these all fitting and accessories are available here. Whatever you're choosing here, the same will be reflected in the bill of material as well as in GTP and the drawings, 3D drawings. You can see the options for cable boxes for both side or LV side, or if you want to the bushings on the side, open bushings or with the cable box. So these all options are available. Even the conservator location, right hand side or left hand side or the length side, these all options are available. So number of fins will change based on the cable boxes. So some fins were going on the pocket. So software will suggest to that. And the pressure required by this tank in PSI are suggested here. Even the bushing type for LV side, if you want epoxy bushing or porcelain bushing, that option is available. The cover type plain or bended, that option is available. Core frame channels, if you want to add like a different kind of channel to use, so that option is also available. And the same what you're choosing here or selecting here, the same will be reflected in the drawings. Now friends, let's see the next page. In this page, you will get the quality card basically. You can see on your left hand side the thermal ability to withstand short circuit forces calculation with the duration and the temperature rise for LV and HV. Here is duration is editable again. Then the no load loss, no load current calculation. In that you will get the magnetizing current, no load current in ampere as well as in percentage. Then the noise level calculation, hotspot temperature calculation, overload calculation, and inrush current calculation. And beside that, in the table, you can see the calculations based on the IEC for hoop stress, bender stress, collapsible resistance. These all calculations are available here. So software will suggest you what number of spacers are required and thickness for that spacers. And here on your left hand side bottom corner, you can see the green color arrow button. Over that arrow, you will get the overload calculation, or you may say loss of life calculation for different overload conditions and the temperature durations. Temperature durations and overload conditions are editable. The next page is for bill of material. Here you will get the total costing of transformer, raw material costing of transformer basically. And this bill of material is segregated as a segment wise. First segment is a cost summary. And you can see here the prices for winding, total core coil assembly, tanking and finishing, others and total. Then winding related information. So you can see the serial number, atom code, material, description of items, specifications, quantity, unit cost, total cost, and remark. Now here, the unit cost is editable. There are two ways to edit. One for this particular design, you can simply edit from here and it will be reflected in the total overall costing. You can see 750. And again, you have an option to change the prices in the database also. So as per your vendors, you may enter the prices in the database. Suppose here 800. Let's save this. So the prices are reflected here. The same for the all materials. Here you can see the materials: copper for LV conductor, HV conductor, connecting flat, tapping conductor, and insulated related details are shown here. Next is the core coil assembly related parts like MS frame part with the dimensions and weight, then the lamination with the core grade, thickness, and the weight. Then tanking and finishing. You can see here the MS tank weight with the dimensions, MS cover weight with the dimensions, CRCA radiators, corrugated fins, and the dimensions and the weight again. Then oil in tank, radiator, and corrugated fins. These all details you will get over here. Next is the other. So what we have chosen on the base fitting and accessories page, the same is reflected over here. And suppose if you want to add more accessories which is not listed, then you can add here and the same will be reflected in the other sections. So this is the way total bill of material you will get. And this bill of material you may export in Excel and add there your labor charges and profit margin and other miscellaneous, and your quotation will be ready. So next is the approval documents. So you can see these documents to provide your customer. First is the GTP, guaranteed technical particular, and all technical information like currents, voltages, connection methods, then the efficiency, regulation, losses, insulation details, then the tank related details, bushing related details, core coil assembly for LV and HV, then the type of insulation, clearances, these all details are available here. You can see the weight details, overall dimensions detail, tap changes details, and fitting and accessories detail. Now, suppose if you don't want to provide these all details to your customers, then you can simply click on print button and you can see on your right hand side one column is appeared and you can deselect which one you don't want. Suppose this 36 number, you don't want this parameters in the report, just uncheck and click again on the print button. So it will be skip in a print and your serial number also will get rearranged automatically. And again, as I told you, the export functionality for the all reports are available here. And this all the pages has functionality for reports. Now next is the core area calculation. You can see how core area is calculated in the winding card. The same calculation is shown here, the actual calculation. Then the flux density calculation, no load loss calculation, no load current calculation, load loss calculation, then fins calculation, or you may say heat dissipation calculation, then thermal ability calculation. Even if you see in the printout, provided in the more detail like formulas, abbreviations, and the conclusion. Then hotspot temperature calculation, current density calculations for LVA and HV. Then there are reports for oil absorption and the symmetrical short circuit current details. So these all customer details are available here. And now let's see the drawings for rating plate and terminal marking plate. Let's see the rating plate first. So software will give you this rating plate. And next is terminal marking plate. You can see what type of trap changer you have selected. Based on that, switch positions, connections, and the HV voltages against the switch positions and the LV voltages. And this connection diagrams where tapping leads are based on the what number of steps are there. Based on that, it's suggested. And the vector group diagram will change what vector group you have chosen on the basic information page. And to fill this template, we have given one template page. Whatever information you are providing here, the same will be reflected in the drawing. Now next is the manufacturing specification where you will get the documents to provide your shop floor. First is the LV specification for LV winder. You can see the LV coils related all information is available on this page. Next is the HV specification. So HV winding related information including the tapping details. Then you can see the HV coil assembly. So for HV side, on the winding page, you can see the 44 number of discs are provided. And in between the discs, 3 mm of duct is provided. And you can see in the middle, brake is provided and the tapping leads are shown here with the tapping number, lead number. And this diagram will change based on what HV winding is there. Like suppose, for example, HV side is crossover winding. So this diagram will change based on that. For layer winding, this diagram could be different. Then HV coil assembly. Here you can see the core to LV gap, LV to HP gap, electrical and physical height, H strips, and the permount ring, top and bottom clearances, how its arrangement in turn. And this arrangement, if you want to change this arrangement, then you have an option to change the insulation page, and whatever you are changing here, the same will be reflected in the drawing. Next is the internal drawing. You can see the HV elevation, side view, LV elevation, and top view. And in this table, again, the information for LV winding and HV winding is provided here. Next is the winding arrangement. You can consider this is the top view of one core coil assembly, and the actual number of steps are provided here. If you change this number of steps in the stack calculation, the same will be reflected over here. Now friends, we have completed the electrical part. Now let's see the mechanical part. In the mechanical, you will get the frame drawing, cover drawing, and tank drawing. Again, the loose part drawing when cable boxes are provided. and the customer drawing. In customer drawing, you will get the GA diagram. These last two tabs are covered under the advanced package. Now let's see the frame drawing. Once you click over the frame drawing, it will open in Inventor software, which is higher version of AutoCAD, and it will give you the 2D and 3D diagram. Again, that diagram are editable by the user. You can see the drawings are generating automatically, and it will take maximum 30 to 40 seconds to generate all drawings in 2D and 3D. So let's see one by one. First is the LV top frame. You can easily check the clearances for tapping lid. We have provided the SS material plate over the cutout to reduce the stray losses. Then this diagram is again editable by the user. Suppose if you are using different kind of channel, then you may simply edit this channel. And the HV bottom frame, LV top frame, LV bottom frame, base plate, tyro drawing, and the all drawings are automatically converted in 2D. You can see the all dimensions and cutouts are given here with the 3D isometric view. And this cutout, the mention as a B and G and C, that all are given separately here. You can see the detail about B, detail about G, the tie rod detail, and the actual weights of the all frame parts. So this is the important part of the software. You will get the actual mechanical weights with the notes and the template. Template is editable by the user. And this diagram you can easily convert in any other form, like in the drawing format, or you may open in the CATIA or SolidX or normal AutoCAD, and there you can edit if you want. So these all functionalities are available here. Next is the cover drawing. So on cover, there are some accessories like thermometer pocket, air release Bosch, explosion pipe flanges, lifting lugs, then the conservator supports, inspection frame, then all flanges related detail like bushing flanges, pipe flanges and all. So this standard details, you will get this in standard file. And you can see the diagrams are generated. So this is the cover. You can see HV side, O ceiling bushing and LV side epoxy bushing are provided. Thermometer pockets, 3 thermometer pockets. Then this diagram is automatically converted in 2D, including the weight details. Then explosion vent, conservator body. These all are the scale to scale drawings, and all tank accessories, cover accessories basically provided here. You can see the conservator dia, conservator length, gap for the buckles relay and the wall, and the exact dimensions for explosion vent, the cutout details, 3D view. Now let's see the tank drawing. On tank, there are again some accessories like lifting lug, earthing terminal, gussets, then the jacking pads, earthing Bosch, pulling lugs. That all standard information you will get over here. And now let's see the tank drawings. So now we have chosen the corrugated fins tank type. So the drawings are generated based on that. We have an option to choose radiator type. Then we have option to choose elliptical tube. We have option to choose pad mounting transformer also. So this is about the tank, and even the number of fins, height of the fin, width of the fin, the exact what we have seen on the tank page here. Let's see the tank length, width, height. The tank length shown here 1550 and the width is 585 and the height is 1425. Let's verify with the drawings. You can see here the inside length as we seen there 1515. The inside width is 585 and the length is shown here 1425, the exactly same. And here you can see the bill of material, the weight for the parts, the tank weight, including the radiators, including the fins. Then tank curve drawing is drawn separately here with the weight details. So this is all about the tank. Now let's see this loose part drawing will appear whenever cable boxes are connected. And I will show you that drawings also. Next is the GA diagram. Now GA diagram is also scale to scale.
Let's see how we can add the cable boxes also
Yes, sure.
on the tank accessories page.
Yeah. For the cable boxes on fitting and accessories page, just wait. Here, you can see the check boxes for cable boxes. Once I check here, we need to save the details. And then here you will get the loose part drawings. So first I will show you the 3D tank drawing, which is already generated here. Then I will show you the uh, this cable boxes drawing also. Now you can see here GA diagram, the 3D transformer with the exact scale to scale dimensions. And this drawing is simply editable by the user. Then you can see the GA diagram is converted in 2D. And overall dimensions are provided here. Now let's see the loose part drawing. For loose part drawing, you will get this standard PDF also and the drawings in 3D also. So let's see the 3D diagrams generating here. So based on the voltage and the ampere, the cable boxes are drawn automatically. So this is the 3150 ampere cable box. And that cable box drawing converted in 2D. Then 11 kV HV side cable box with the 2D and 3D. So this is all about the cable boxes. Now, friends, I'll show you the one more design for power transformers where the transformer tank type is different. Now, let's say new design for 10 MVA webinar. You enter any design number, any work order number, then rating. Let's enter 10 MVA. Once you enter 10 MVA, it will suggest to the voltages also, and you have option to change the voltages. So 33 is the HV side and 11 kV for LV side. Then based on that, you can see the lighting impulse and the highest withstand voltage shown here. You have an option to change this pulse also. Then the reference standard, let's say IS. Then vector group software has a delta delta option, delta star option, delta star star option. So these all options combinations are available. Then efficiency level, level 1, level 2. Again, the losses, you can see the on your left hand side, the losses will decided based on this. And you have an option to change the losses as per your customer demands. Then impedance is suggested by the software automatically based on the reference standard. Even the tolerances are suggested by the software. Flux density, core building factor, then cooling types, then tapping. Now let's see the OLTC now. For OLTC, the tapping range is suggested -15 to +5 and the step variation is 1.25%. So total 17 positions and 16 number of steps are there. Then the conductor material, copper and aluminum, both options are available. Then core type is D-type step lap, S-type step lap. In D-type, you will get the top and bottom yoke is half circle basically. And in S-type, you will get top and bottom yoke are full circle. And elliptical core option is also available. Then type of tank, let's say radiator type with conservator now. Then type of class of insulation. For dry type, it will suggest to F and H class. Then impedance, ambient temperature, oil temperature rise, winding temperature rise, reference temperature. Based on what reference standard you have chosen, it's suggested by the software. Even the losses, current density is suggested by the software, but you have an option to change these values on the next page, or current density you may change on this page. So with this parameter, like 10 MVA, 33 by 11 kV, DYN 11 with the impedance of 8.35%, and the OLTC with the tapping range -15 to +5 and the tapping variation 1.25%, copper radiator type with conservator, and this temperatures 50, 40, 45, and the 75 is the reference temperature. So with this information, I'm going ahead on the winding page. You just need to click on next button, and based on that, your whole design will generated automatically. Now you can see again on your right hand side that 10,000 kVA, 33 by 11 kV, DYN 11 and ONAN. Now below that table, you can see the parameters, units, LV winding detail and detail for the minimum rated and the maximum tab. Now let's see the row wise. First row is for area per phase. The second row is for current density. Then length mean turn, conductor length, bare weight, insulated weight, resistance, I square R losses. Now I square R are calculated on 75 degrees Celsius, but you have an option on basic page to take at 95 degrees Celsius also, or any degree Celsius. It will convert automatically. Then the eddy losses, gradient, then below that table, there is one more table. You can see again the row wise reactance, impedance, total I square R losses, AD losses, stray losses. Now this AD and stray losses is calculated based on the Westinghouse formula. But you have an option to change as per your thumb rule, like 15%, 10% or 20% based on the KVA ratings. You can simply enter here and click on redesign button. Then that ADN stray will be constant and the I square R losses will redesign based on that. Then no load loss and load loss, then resistance. Now you can see the no load loss guaranteed and the maximum no load loss. Here the maximum no load loss is available to edit. Now, beside that, on your right hand side bottom corner, you can see the core area, core diameter, center length, leg length is shown here. Now, beside that, core grade, flux density, core loss, current density. Once design is saved, these parameters are editable. So meanwhile, I will explain you the table, the bigger one on your right hand side. You can see again there also, if you see the column wise, first column is for parameter, second for unit, third for LV winding detail, and the last for HV winding detail. Now, row wise, first row is for type of winding, LV side disc winding, HV side disc winding. So based on the amperes, this winding types, suitable winding types are suggested in the drop down list. The software has 7 number of different windings. For example, layer, crossover, layer crossover, disk, foil crossover, foil disk. These all options are available. Now you can see the suitable options are available here. Then the winding directions, then normal, minimum, and maximum turns for HV side and the normal turns for LV side, number of disk for LV and HV side, then turn per days. Then in between this, there is a gap. 3 insulation is provided. The blocks, insulation blocks are provided there. Then type of conductor, software has a rectangular conductor and the round conductor option also. So suitable based on the current, the suitable options are available in the drop down. Even in the type of covering, we have options for DPC, TPC, super enamel, and TUPC, thermally upgraded paper covering also for a converter inverter duty, and the KNA ester oil. Then radial and axial number of conductors, total number of conductor sizes. These conductor sizes are editable. Suppose if you have any existing conductor size in your stock and if you want to redesign the job with that conductor size, you can simply edit the conductor sizes. Once you edit, redesign button will appear and you can click on, for example, here if you want 12 and 2.5. So once I click on redesign button, whatever parameter you have changed with the white background cells, that all are appearing over here. And there is a message you can see, do you wish to continue with the following parameter as a fix? So whatever parameter you have changed, that all are appearing here. And once you click on OK, then that parameter will constant and your remaining design will generate based on that. Then again, you can see the core to LV gap, LV to HV gap, IDOD of the coils, electrical height, then the height of insulation, then total overall height, then top and bottom clearances, and including top and bottom clearances, you will get the total leg length here. Now, I'm not going to save this design with the changed parameter. So this is the already saved design by the software before I change the conductor sizes. Now you can see the core grade. Software suggested M6 grade. Now this core grade will impact on the no load losses. You can see the no load loss. The guaranteed no load loss was 9460 and the software has designed 9459, which is very near to the guaranteed. Same you can check with the load loss. 65,000 around is the approximate no load losses, and these are also around 64,946. Then this core grade, you can check now the no load loss. The no load loss, if you want to reduce the no load loss, you can simply change the core grades. And still, if you want to fix that core grade, you can fix and click on redesign. So it will take action on the flux density and you will get the desired results. Same for the flux density. And if your core manufacturer is giving this different watt per kg for the same core grade and flux density, then option is available to change. Suppose if you don't have any core grade which is not listed here, for that also you can use this functionality. You can simply enter the watt per kg for that particular flux density and the same will be reflected in the no load loss. Then current density option is available to choose here. You may fix the current density from here. Click on the redesign button. Now on your left hand side, you can see the stack calculation. So now number of steps are generated 13 and these blade widths are available here, which is again editable. Now suppose if you want to change this number of steps to 11 or 9, for example. So keeping the same core diameter, window width and window height, these steps are rearranged automatically. And you can see the stacks, design stack, net area, the dimensions for side, center and the middle limb is given here. Now ratio error calculation. You can see now OLTC is chosen and based on that tap positions, taps, HV voltages, voltage ratio, design turns, actual turns, step turns, turns ratio, and the percentage error is given here. Now next, here one more panel is available. where you can see the bus bar sizes, losses, bus bar losses and bushing losses are added here. Suppose if you're choosing the converter inverter duty transformer, that time bus bar losses, the more bus bar losses are added here. Then the losses on 50% load, 100% load, losses on lowest and highest tap, zero sequence impedance, impedance at lowest, normal and highest tap, turns K factor, face-to-face clearance, transposition. Now this finding, that's why transposition is zero. Then number of circles are provided here, and the same will be reflected in the insulation and the drawing also. Now this duct setting is available for elliptical tube, then the amorphous core and wound core. In the duct setting, you may choose the different kind of ducts for a width side and thickness side. Even the gaps, core to LV gap and LV to HV gap, if you want to choose different gaps for the both side, width and thickness side, so that is also available to change from this page. Now we have chosen the step lap core. That's why this setting is disabled here. Next is the core chart. Again, you can see the drawings here and the detailed core chart. So figure 1, figure 2, figure 3 for side, center and top and bottom, and this kind of assembly will get here. And the dimension for blades for side, center and top and bottom view, and the weights detail is provided here. Next is the insulation arrangement. Again, the white cells are editable. You may rearrange the insulation, what existing practice you are using now. The exact insulation weight you will get over here. Then core to LV gap, LV to HV gap with the validations. If you enter any wrong value, software will suggest to the correct one. Then next is the tank, radiator and conservator detail. Now you can see this page is changed. The radiator arrangement is changed. For tank side, you can see again that two images. The first image is the top view and second image is the front view. In the first image, top view image, you can see A, B, C, D are the clearances, same are mentioned in the table, which can be editable again. And in E and F is the top and bottom clearances. So 120 is the E and 25 is the F bottom clearances. So this is the way you will get the total tank dimensions, and the same will be reflected in the 3D diagrams as I shown you earlier for the 1500 kV. Now you can see on right hand side table, the tank dissipation, radiator width, multiple options are available to choose. So with this functionality, you may rearrange your overall dimensions also. For example, 226, 300, 380 and 520, the available sizes, which is available in the market, that sizes are given here. And based on that, your number of fins per radiator will change automatically, the downside. Then the center distance. Center distance means radiator pipe to radiator pipe distance here. And this 520 is the width of the radiator. The number of radiators are 6. These radiators are again editable. Then the fins per radiator are 29 and the total number of fins are provided here. Then the section weight and oil in radiator, how much oil in the radiator, that is also shown here. Then conservator diameter, length, volume, and the oil in conservator. These all details are available here. Again, the cells with white background are editable, and the same details, what you have seen here, the same will be reflected in the drawings. Let's see the fitting and accessories. You can see here for 10 MVA, the side plate thickness, top and bottom plate thickness are suggested by the software. Radiator type. Software has a welded type radiator, detachable radiator, then Buckos relay, MOG, PRV, these all details. Then OTI, WTI, these all options are available. Now the major thing here, the OLTC model. Now software has in-tank option also and the external OLTC. For external, we are using the CTR models, and the based on the voltages, the suitable model software will suggest you. And for in-tank OLTC, you have an option to choose here. For MR, is an MR make we have added here, as well as OLG make also we have added here. So 3 makes you will get over here, which is available in the market. Then WTI city. Suppose if you want to use this city in the U phase, V phase, or W phase, so that all options are available. Neutral city option is available. Let's set neutral city. Then these all options like which how much inch pipe you need, and the conservator pipe, core filling cap, then the bushing, cover type, tank frame sizes, even the cable boxes. These all details are available to choose here. Now next is the short circuit detail. Again, the detail for temperature rise for LV and HV for a short circuit is given here with the duration and the temperature rise. Then the no load current calculation, in that you will get the magnetizing current, no load current in ampere and percentage. Then the noise level, hotspot temperature, overload calculation, inrush current calculation, then loss of life calculation. And in this table, you will get the calculations based on the IEC again for bending stress, slope stress, collapsible resistance. Then the bill of material. This is the total bill of material, and let's see the section wise. First section is for cost summary, then winding related all information, core coil assembly related information, tanking and finishing. Now you can see here the tank dimensions, cover dimensions, radiator dimensions, then oil in tank, radiator conservator, as well as oil in the OLTC. Then others. Now you can see much more accessories are added for power transformer, this 10 MVA transformer with the all details. And if you don't want any accessories from here, you can simply select and click on minus button. So that will be skip in a print. Or you may go to the accessories, uncheck the accessory and save the page. The same will be reflected in the bill of material. So this is the way you will get the bill of material. Now next is the approval documents. So GTP for power transformer. So 5 pages of GTP you will get over here. And again, as I explained you, the option is available to change the format of GTP to arrange the serial number or give the information whatever your customer is asking. So based on that, you will get this GTP. Or you may change the serial number, you may skip these parameters. These all functionalities are available. Or simply you may export in Excel and change the parameters there also. So all the options are available. Then you can see the actual core area calculation, how it's get calculated, flux density calculation, then no load loss calculation, no load current calculation, load losses calculation, pins calculation, thermal ability calculation, hotspot temperature, current density calculation, oil absorption report, symmetrical short circuit current calculation. Then drawings. Again, here are the drawings in 2D basically. Then you can see the fitting and accessories drawing we have shown here with the dimensions. Then rating plate diagram. This company name will change here automatically, and the as based on the country name where we are installing, at a type of installation we are choosing the country name and currency. Based on that, the currency and country name will change automatically here. And this customer name, order number, month and year of manufacturing, serial number is based on your practice. You can engrave or emboss here. Then next is the rating terminal marking plate. Here you can see the OLTC related tapping details, like switch positions, connections, HV voltages, LV voltages. Now you can see as I chose the neutral city and phase city, and the phase city, as I said, you have an option to choose in the middle or in the U or V phase also. And these connection diagrams are based on the tapping number of steps. Then this vector group diagram is based on the vector group selection. Next is the manufacturing specification, LV specification for LV winding, then HV specification, You can see the tapping details here. Then here the details for leads and HV number of disks and the gap between disks. Then core coil assembly detail here. Internal drawing and the winding arrangement diagram. You can see the number of steps are exactly same what we have provided or software has taken in the stack calculation. Now let's see the mechanical drawings for this. So we have completed the electrical part and these last two tabs are under the mechanical drawings. In mechanical, let's say the frame drawing first. So for these drawings, you need to have Inventor software installed in your computer. And this drawing opening speed is depend upon your computer configuration also. So it will take maximum 20 to 40 seconds basically. Now you can see the core frame channel construction is different than the distribution transformer here. You can see the cutouts here. The clamping ring is there. This is the HV top frame. Then LV bottom frame. Base plate. Tie rod detail. And the all drawings are automatically converted in 2D with the all dimensions. Now the cutouts are mentioned here as a B, C, and that are given separately here. You can see the detail for B. Mechanical weights, and some important notes are given here. And the template is editable by the user. Now let's say cover drawing. Again, some accessories and relative accessories will open here based on the KVA rating. And you can see the drawing is generating here. Now, suppose if you want to modify this drawing, then you have an option in the software also. You can simply go to the tank page, change the conservator dimension, and the same will be reflected here. Same for the tank also, same for the radiators also. And again, if you want to change some whole dimensions and all, then these drawings are fully editable. Even suppose if you want here these bushings on the side tank, so that options is available. Then bushing types, epoxy or this porcelain material. So that is also available to choose. You can see this drawing body. Then explosion vent. Then conservator body. Conservator dimensions. You can see the conservator length is shown here 1350. The same you will get here. The conservator length is here shown in meter, 1.35 meter is exactly same in the mm. Then core diameter is 600. Again, the gaps for workers relay and all. Then the mechanical weights. To calculate mechanical weights are a complicated task for a designer, but this software makes this simple. Then next is the tank drawing. On tank, again, there are some accessories which shown on a separate page. And here the drawing is generating. It's automatically. You can see the OLTC model and the stiffener arrangement, base channel, the radiator arrangements, and whatever fitting and accessories you have chosen. Based on that, the modifications are automatically done in this software, in the drawing. Again, let's check the dimensions also. The inside length is 2335 and the width is 845. Let's verify the same. You can see 2335 is the length, width is the 845, and the height is 1790. Let's see the height also. So if you change the height there, height or this radiator distance, the same will be reflected in the drawing. You just need to save. Click on the save button. You can see the height here, the exactly same 1790. And the 3D view, isometric view is given here to understand more clearly. And this is the part list and the exact weight of the mechanical part. So software is calculating area itself and we have provided the material and based on that, the weight is calculated automatically. Then the tank curve, 2D and 3D. And in the bill of material, the same weights are added there also. Now let's see the GA diagram for power transformer. There's a message to open the drawings. So for GA diagram, it will take maximum 40 seconds basically, and remaining diagrams, it will take maximum 20 seconds. It's again based on the computer configuration. So the both 2D and 3D are generated. You can see the bushings. Even the bushing petticoats are based on the voltages reflecting. This is the scale to scale diagram. You can see the number of fins are provided exactly same what we have seen on the basic info on the tank page. The number of radiator center to center length, the exactly same. So this is the way you can visualize this three-dimensional drawing for transformer what you design. And now I just want to show you the one more drawing. Now here, suppose if you want drawing in the this in tank OLTC, just need to save and check the drawing. Let's see the tank drawing. Again, some accessories. Tank cover is not updated at my side. But this is the way you will get the diagram with the circle arrangement for the OLTC, in-tank OLTC. And now I want to show you one more thing as a user manual, what other things are covered in the software. Let's see, this is the index. Then you can see the reference standards, suitable reference standards covered in the software. Then the efficiency, what is meant by level 1, level 2, conventional. This cooling types, available cooling types are explained here. Then the winding types, as I told you, these winding types are appearing based on the current. The suitable winding types are available in the drop down for winding type selection. And we explain this winding type, what we have done in that. Then core building factor, material densities for weight calculation, and what kind of paper covering we have. Then the CRGO related information, stacking factor for different core constructions, core densities, watt per kg chart for core grade and flux density. Then the losses as per BIS, then the core construction details. You can see software as S type, D type, and then the wound core construction with the shell and core type. And here the material is different. The construction is same shell and core type. Then elliptical tube option is also available here. So you will get this type of core coil assembly if you consider the top view. And then rectangular core option is also available. So certain options like amorphous core, wound core, then this rectangular core is available up to 500 kVA. AI core, then insulation classes, then material for dry type and all type transformer. Then winding parameter we explained, suppose if we change the nomenclature, then the insulation arrangement for different core type of construction. For S and D type, you'll get this type of construction. For elliptical wound and amorphous core, you will get this type of construction where width and thickness is there for core. Then coil tracing procedure, like how much pressure before ovening you need to give for LV and HV and both, and how much time you need for ovening, and after ovening again how much pressure you need to give with the hydraulic jack. Then interlayer insulation formulas. So Mr. A.V. Chiplunkar sir's formula we have provided here. Then the conversion of mil to then gaps where to use mill paper, duct, and block. That all information is provided. Then the gap between core to LV, LV to HV. The minimum and maximum limits are given here. Same for the end clearances. Then current density, impedance. As Mr. Rajesh told you, the 2% manufacturing tolerance is considered in the impedance. So that is also mentioned here. Then the efficiency variations, unit rate changing procedure, then the silica gel breather, where to use what weight for the silica, suitable weights for the transformer rating, silica for silica gel, then the Buckos relay, where to use GR 1, 2, 3, the suitable kVA ratings, and the details for that GR is given here. Then tapping details. The purpose here, we have provided here the number of leads and the number of steps, number of positions with the different ranges. You can see here for on-load tap changer, the available ranges like 22 type of different variation. And software has option to enter any range, not only this range. Then lifting lug weight bearing capacity, how it's getting calculated and what reference standard we used. Based on that, this information is also provided with the formulas. Then these are some fitting and accessories what we are using. So the copper clad aluminum is shown here. The construction type for amorphous core, wound core with 4 loop, rectangular core. And these are the some frequently asked questions by the customers that are also we are maintaining here. Now, if you have any question, you can unmute yourself and ask us. We are happy to answer you. You may unmute yourself, and if you have any question which is not covered, you may ask us.
Hello, can you hear me?
Yes, sir.
Yes, please.
Thank you for the presentation. Just a quick question. Is there any plan to develop the tool towards using heat exchangers on the cooling system?
You mean
You mean heat exchangers?
you mean the
Yeah,
radiators and
The water cooled system.
water cooling systems. Okay. See, this is typically what we are
Okay.
providing here is for the transformers, and we are not detailing into the heat exchange parts and the design thereof. So it is limited to what we are showing it here. Daniel, where do you come from?
From Vestas.
Okay. I'm glad to be knowing that you have been attending this. But what you have been seeing here now for the mechanical designs of the transformer, we are absolutely limiting to that only.
Okay, thank you for the clarification.
And friends, I would like to show some of the testimonials that we have received from the many users of this particular software. And you can see here, this is from a company.
yes. Computer screen is not visible yet, sir.
Not visible. Okay, fine.
Showing it started, screen sharing started, but it's not visible yet.
Okay, let me. Yeah. Yeah, friends, I'm sharing the screen now. I hope it's visible now to you.
Yeah.
Friend, this is a company based in Macedonia, and this was one of the latest testimonial received from them. And they've been using this software since Jan 2024 for transformer designing up to 12.5 MVA. And another one is for this company. They issued this in the month of February, and they have been using this software for designing up to 40 MVA. And they have been using it since October 2023. This company has been using up to 10 MVA, this software, up to 36 kV, and they've been using it for over a year now. This is from another company. They've been using it since August 2023 for designing of the transformers up to 3 MVA. This is a company based in South Africa, and they have been using it up to 10 MVA since October 23. This company is in Peru, Latin America, and they have been using this software up to 50 MVA, the voltage class being 138 kV, and since October 23. This company has been using this software since April 2018 for designing transformers up to 10 MVA, 36 kV class. This is the company in Turkey, and they've been using this software since May 2023. This company based in India using this software since July 2022. This company has been using it for quite some time, since February 2018, for designing transformers up to 10 MVA. This company has been using TDBro software since October 2021. Maximum rating that they design is up to 12.5 MVA, voltage class 132 kV. This company based in Pakistan, they have been using the software up to 40 MVA 132 kV class since Jan 2022. This company have been making use of this software since March 2018 for designing transformers up to 10 MVA. This company used the software to design the transformers up to 10 MVA since last 4 years plus. And they have designed the transformer, they manufacture the transformers, and they got the unit tested. And they are mentioned in the table there in the certificate how much were the losses guaranteed, how much were the designed as per the software, how much were the tested parameters. So this is the testimony of what accuracy this software is. It's another company who has been using the software since April 21 for up to 10 MVA 36 kV class. This company has been using software since January 2018 up to 10 MVA 36 kV. This company has been using the advanced package up to 10 MVA since Jan 2021. This is one of the oldest customers for us who has been using the software since 2013, over 11 years. They are based in Ghana, African country. This is a company based in India. They have been using the software up to 10 MVA and using this software since May 2018. This company has been using the software for quite long time, since 2019, up to 10 MVA. This is the company using mechanical designs as well as electrical designs since March 2020, up to 10 MVA. This company has made use of the software to design the transformers, manufactured and got it tested at one of the very reputed standards organization named Central Power Research Institute in India. And they got these 2 units manufactured and tested over there. And they certified that the units passed. This is a company based in Zambia, Africa, Tanilek. They have been making use of this software since August 2017. There's a company named Homac. They have been using the software since December 2016. This company has been using the software since Jan 2018. This company has been using this software for quite some time, since February 2016. 2016 up to 5 MB, and now they are likely to upgrade the license to 10 MB. And this is a company based in Turkey, and they're using it since March 2019 up to 10 MB. This company has been using the software since April 2017 up to 10 MB 36 kV. Friend, these are all the kinds of testimonials that we have received, and that shows the kind of confidence the industry has on the support, on the accuracy, and on the benefits that the software accrues to the users. Friends, what you have seen, the complete graphical user interface of the software is in English language, and we can provide the option to print the design output in the language of user's choice too. And this design software is desktop based. It is not cloud based or internet based. That makes whatever design changes on your computers absolutely safe and not available to anyone, including us. And friends, knowing this, one question that may arise in your mind is, how about the pricing of this particular software? And let me show you the pricing of the software depends upon major three factors. And which are those three factors? Let me take you over there. Friends, the pricing of the software will depend upon the maximum rating of the transformer. It depends upon the license period, whether you want it for 1 year, you want it for 2 years or 3 years. And then it depends upon the number of licenses you would like to have. And also it depends upon how many computers you would like to have this software installed. And these are all the factors on which the pricing of this particular software will be dependent on. Now, if you have any further questions, friends, please feel free to ask, and it will be our pleasure to answer to your questions.
Hello, sir.
Yes.
I want to know that the AutoCAD software must required for mechanical designs.
In this particular software, TDBro, you need to have the Autodesk Inventor to generate 2D, 3D drawings, not the other software. But if you have one license of Autodesk Inventor, you can have this 2D, 3D drawings generated, and then you can copy and paste in other softwares. It could be AutoCAD, it could be SolidWorks or any other, and open and edit as necessary.
Okay, sir.
Yeah. Any other questions, queries, doubts? Friends? Any other questions?
Hello, sir.
Yes. Yes.
From engineering group and power equipment manufacturing industry from Ethiopia. Your
Okay.
presentation is, we will try to work together.
Sure.
For us, it is a good opportunity.
Yeah.
And we can discuss further how we can work together.
Definitely, sir. We remain to support the industry worldwide, and we are a long-term player, and we have already been in the industry for over 3 decades, and we remain to support whatever support you need in terms of transformer designing capabilities or in terms of setting up the transformer test laboratories. We remain.
We can, in terms of design software and the other, what we wanted to about not only transformer. I think this transformer, this design software is work for inverter and the charge controller also, and for dry type in the oil immersed transformer. Went to buy